Lesson 5, Equation of a Straight Line, Part 1. The equation of a straight line is the relationship that exists between the two coordinates x and y of a variable point on the line. Gradient intercept form of the equation of a line. If a linear equation is written in the form y equal to ms plus c, where m stands for gradient and c is the constant, the graph of the equation is a line with gradient m and y intercept. That is the point where the line cuts across the y-axis is the y-intercept. At that point, s is equal to 0, y is equal to c. Examples: find the gradient and y-intercept of each of the following. Number 7, y equal to 4s plus 2. In order to find the gradient and y-intercept, the given equation must be written in this form. The given equation is already in the required form. Hence, the gradient m is equal to 4, coefficient of s. Then the y-intercept c is equal to 2, the constant. Example 8, you have 3s minus 5y equal to 15. Solution: to find the gradient and y-intercept of the line, you need to write the equation in gradient intercept form. That is y equal to ms plus c. Y equal to ms plus c. You do this by solving for y. So this is the given equation. To solve for y, y needs to be positive. To achieve that, let's transfer this term to the right. It becomes positive. You transfer 15 to the left, it becomes negative. Therefore, 5y is equal to 3s minus 15. To have it in this form, y needs to stand alone. So divide through by 5 the coefficient of y. You have this result. The final result is now in the gradient intercept form, where m, the gradient, is equal to 3 over 5. The y-intercept, c, is equal to minus 3. Hence, gradient is 3 over 5 and y-intercept is 0, c, that is minus 3. At this point, s is equal to 0. So the point where the line cuts across the y-axis is the y-intercept. That point is minus 3. The next equation is 1-point gradient form of the equation of a line. Recall that the gradient of a non-vertical line AB passing through points A and B is given as gradient m equal to change or increase in y over change or increase in s. Here we are considering just one ordered pair, s1, y1, and q is any other point. If you trace both points to the s-axis, y-axis, you have the two distances between the various points. From the figure above, let M be the gradient of the line PQ of the points P and Q respectively. The gradient of PQ is defined as M equal to increase in y, that is y minus y1 over increase in s, that is s minus s1. If both sides are multiplied by s minus s1 in order to clear fraction, we have the gradient M times increase in y equal to increase in s equal to increase in y. This form of linear equation is called the point gradient form. You have one point, s1, y1, and the gradient M. It can be used to find the equation of a line when the gradient and a point on the line are given. Examples number 9. Write the equation of a line that has a gradient of minus 6 and passes through the point minus 1, 10. Express the result in gradient intercept form. This form is y equal to ms plus c. Solution: we use the point gradient form since the gradient and a point on the line are given. Such equation is equal to this, multiplied through by s minus s1 to clear fraction. So from here, y is a point minus y1, that is 10, equal to the gradient is minus 6, bracket open, s is a point minus s1, which is minus 2 in bracket, you close the outer bracket. When you simplify, you have it in this form and this result. In gradient intercept form, y always stands alone. So let's transfer minus 10 to the right hand side. You have it in this form. Therefore, y is equal to minus 6 minus 2 in gradient intercept form. Equation of a line through 2 points. Consider the figure below. You have point P in the figure. You have point Q and another point arrow between points P and Q. If you trace this point to this place, you have S1, here is S, you have S2, so that the distance from S1 to S is S minus S1. You have the same between the 2 points here. The figure above shows a straight line passing through 2 points P and Q, which takes any point arrow in the line. Then gradient of RP. RP is y minus y1 over s minus s1, and gradient of PQ, the entire line, is y2 minus y1 over s2 minus s1. That is the change in y over change in s. Hence, the gradient of the line will be the first gradient equal to the second gradient. So, if we are to find the equation of a line passing through 2 points, we use this formula. Examples number 10. Find the equation of a line that passes through these 2 points. Solution. The first ordered pair implies S1, Y1. The second ordered pair implies S2, Y2. Since we have 2 points, the required equation of the line is given by this formula, where y1 is equal to 0, s1 equal to 4. So you have 0, 4. y2 equal to minus 8, s2 equal to 6. You have them in this form. This is y1, then s1. If you simplify this side, you have minus 8 over 2. Y minus 0 is y over s minus 4. If you simplify this side, you have this result. Next, you cross multiply to clear fractions. Y times 1 equal to y minus 4 times this term in this form. When you open this bracket, you have y equal to minus 4s plus 16. End of lesson 5. There is every need for you to be saved if you are not, because the Lord Jesus Christ is coming very soon. Some will be taken and some will be left. Live righteously and be prepared. Goodbye.